So we're starting off Unit 1B today, which focuses on angles and also angles within parallel lines. Today, the first lesson here, 1B.1, will be a review of angle relationships that you talked about probably in middle school, so I know you probably need a little bit of a review on that. So I have it broken down here, so we'll name the relationship, highlight the angles in a drawing so you can hopefully identify those from that, and then a what you need to know section. So this one you're going to use quite a bit if you need to refer to that on how to write the equation and things when we get into that here in a minute. So first one is vertical angles. So on each of them I'm going to name one, and then we'll say you pause and try to name one. Okay, so I'm going to start and do AFC. So that is actually these two angles together, and that's okay. I can name an angle that includes two. It's still an angle on its own. So angle AFC is going to be a vertical angle to angle EFD. If you remember, I put those two swoops because they are going to be congruent, okay? The swoops mean congruent. So for vertical angles, you need to know they're located across from each other like this. It says on two intersecting lines. So remember, that's looks like this where they cross. Alright, and then when you're writing the equation, what you need to know is they're going to be equal to each other. So EFD was our other. Alright, so go ahead and take a minute here, see if you can name another set. Okay, hopefully you found another set of angles, and what your only other option really would be AFE. And I highlighted there, and remember I put two lines because it's not congruent to our first set, but it will be congruent to CFD over here. And if you notice, all of these intersect at F, so they all have F as their middle letter. Okay, our second one here is adjacent angles, and these are not one that you're going to use very often in solving an equation. They may just kind of say like two adjacent angles, and that's going to mean that they are just beside each other, okay? They're not necessarily congruent. I mean, they could be, but it's usually just kind of a very rare thing there. So if we're looking to set up an equation for that, we really can't do that. So this is just something we're using for locating them. There are lots of examples on this one. I'm just going to start with AFE, and then I'm just filling in to show you where that angle is, not that it's congruent. So angle AFE would be adjacent to angle AFB. And if you're looking, well, they're adjacent, and so that means they share a vertex here and that one side. So you can see then they both have AF in their angle name. Okay, I could also do angle, let's see, CFD. So why don't you take a minute and see if you can name the other, or the angle that will be adjacent to CFD. Okay, so you actually had two options with CFD. You could have done BFC, or I'm going to call that CFB actually. That way we can see that overlap with the CF there, CF there. Or you could have done DFE, which then they would share the DF. Okay, we're going to skip this last little line because there's actually quite a few more we could do. Alright, next set is linear pair. Oh, and quick note on your highlighting, I would make sure you may just want to highlight like the first angle that we say, just so you have a clear picture of what that angle relationship is. Alright, so linear pair is two adjacent angles, so meaning beside each other, that form a line. Or you can think they add to 180 degrees because that's what a line is equal to. So for your equations, they will be when added together. Sorry about that switch. Now one thing that's important for this is they are adjacent, so beside each other. So, and pair we know means 2. So I'm going to start and say, I'm going to do one of those inclusive angles again. So I'm going to say AFC. Okay, so the linear pair to AFC, and here we have two options. I could either do CFD or AFE. So I'm going to do AFE. And I know, okay, they're adjacent. They both have AF in their name, so they're sharing that ray there. Now you want to look, okay, these do not look congruent, right? AFC is obtuse, AFE is acute. So you really want to kind of try to do a visual check when we start getting into some of these solve for X problems. All right, so that's all I would highlight on your drawing, but just to show you where the other set is, I would say CFD and angle EFD. So again, they form this line, yeah, this one and this one. Okay, and the next one here is really, really similar. So supplementary angles are, I'm going to put 2 or 3 angles that add to 180 degrees. Technically it could be more, but usually that's the max you're going to see. So they're very similar to linear pairs, except they don't necessarily have to be adjacent or necessarily have to be 2, but they are still going to be equal to 180 degrees. So if I wanted to use 3 angles for this, I could say angle EFA, then I could say angle AFB, and to complete that 180, I could say BFC. Okay, so now the bottom set down here is actually a linear pair, or we could say supplementary, since those are kind of interchangeable. And when you get to homework and things, I would accept either. So go ahead and take a minute and see if you can name those 2 angles. Okay, hopefully you found those 2 at the bottom. So we would say angle CFD. Of course, remember you can do this backwards. You can do DFC in that case. And angle EFD or DFE, either way. And those were adjacent, so they share FD in both of their angles. To 180 degrees. Okay, the last relationship here is complementary angles. So these are 2 angles, most often 2, that add to 90 degrees, or you can think that they form a right angle. So we're going to be looking for a little square in there to prove that it's actually 90 degrees. So in this picture there are only 2. So I want to use this angle CFD, which is right here, and angle BFD. And as you see, they are adjacent and they have FD at the end of them. Quick note on this one, I could not use, I have seen kids where they try to say EFB. I could not use that because if I add anything to that, it's going to be more than 90, because since that shares this line with this one, they are going to already be 90. Sorry if you hear my dogs barking. Okay, now this part is definitely a review. So classifying angles, acute is when an angle is less than 90 degrees. So it looks something like this. Obtuse is greater than 90. And it's going to be really a wide opening. A right angle is exactly 90 degrees. And remember, it's going to have that square for you, just because we can't really tell the difference between maybe 89 and 91 and 90. And then lastly, a straight angle. So a straight angle is actually basically a line. So it's going to look like a line, which is 180 degrees. Sometimes they will put points on it to name it, so maybe like A, B, C, where technically B is the vertex, but it's really just a straight angle. Alright, now finding those unknown measures. This is the fun part. So here's kind of some steps for you to follow if you get stuck on these. Draw the picture of the given information. That is pretty much always going to be what you start with in geometry, because there's pretty much always some sort of image that you can label and help you figure out, hopefully. Determine the relationship between the given angles and the angles you're trying to find. So this is going to be one of the 5 that we discussed today. So vertical, adjacent, yes, but you really don't use that very often. Linear pairs or supplementary you can use interchangeably, or complementary. So number 1, given angle A is 38 degrees, find the supplementary angle and classify it as acute, obtuse, right, or straight. So I'm going to start with the angle A. So I know 38 is an acute angle. Okay, that's angle A. It's 38 degrees. And it says find the supplementary angle. Okay, well, I know a supplementary needs to come off of that line, off of that angle, and form a straight line. So I am looking for this. Well, if it's a question mark, I can use an X. Right? It already told us the relationship for this one. It said it was supplementary. So for my step 3 here, I know supplementary, if I look back at my notes, the equal to part would be equal to 180. So this is still really similar to last unit when we did angle addition. So I'm going to do, well, one part of that whole angle is 38. The other part is X, and the total is 180. So yes, this one could be done shorter because it's a very simple one, but when we get to the harder ones, so I'm going to subtract 38 from 180 essentially. If you did that to begin with, that is okay. I just want to show you the method for when they do get a little more complicated. So if you subtract that out, you should get 142 degrees. And then it also says to classify it. So acute, obtuse, right, or straight. Well, this is greater than 90, but not 180 yet. So that is obtuse. Alright. Would you guys pause and see if you can do number 2 on your own? Okay, hopefully you paused and are now just checking your work. So it said angle A is 43 degrees. Find the complementary angle and classify it as acute, obtuse, right, or straight. So again, 43 is acute. It's angle A, 43 degrees. If I'm looking for the complementary angle to that, I am talking about a right angle. Okay? So this angle here is my question mark. And you could have drawn this a little bit differently and that would still been correct. So I know, okay, complementary, the equal to part of my note says they are equal to 90. I'm going to make my question mark X. So I could say X plus 43. So again, still part plus part equals whole. Just I know if it is complementary that the whole is 90. Okay? So again, this is a simple one. You just subtract 43, and that gives us X equals 47 degrees, and that is an acute angle. Alright, hopefully those first couple were pretty simple. We're going to go a little bit further here. So construct vertical angles and label them 1 and 2. So vertical angles need to have an intersection, 2 intersecting lines. They might have other lines put in there, okay? But they're for sure going to have those. So I could not do adjacent angles because those are beside each other. I want to do vertical means like across from or directly opposite. So you could either do 1 and 2 this way, or I could do 1 and 2 this way. Just because it's vertical doesn't necessarily mean up and down, just means like across from. So I'm going to do here and here. Alright, it also tells us the angle 1 is 84 degrees. So what is the measure of angle 2? All right, well, if they're vertical angles, that is my relationship down here that I need to tell. Vertical angles. And I also want you to put in parentheses when you're naming these what that means. So your answer should either be congruent, equal to 180, or equal to 90. So I know vertical angles are congruent. So then if I'm writing my equation, okay, well, angle 1 is congruent to angle 2. So I could say, well, angle 1 is 84 degrees, and that's going to equal angle 2 is my question mark or my x. So 84 equals x. If I want to flip that symmetric property, x equals 84 degrees. And that's all I need to say. It does not say to classify this one, so we're done. Alright, 4. Construct a linear pair and label them angle 1 and angle 2. So a linear pair looks like a line. And it says angle 1 is 48, so that's going to be my acute one here. So angle 1, angle 2, angle 1 is 48 degrees. I am looking for number 2, so that can be my x. And then if it's a linear pair, I know that the whole is 180. So relationship, again, they told us on this one, it's linear pair. And don't forget to tell what that means. Well, that means they equal 180. Or you can say add to 180, either one. So if I'm going to write an equation here, I would say x plus, so part plus part, x plus 48 equals 180. Going to subtract 48, and x equals 132. X was angle 2, so I'll go ahead and write that final. Okay, now we're going to throw in a little bit of an expression here, kind of like we had on the last unit, so these are more fun. Alright, so when it says property, same thing as relationship, okay? So property or relationship are kind of interchangeable here. It means what is the relationship between the two angles, either the ones they give you or the ones you're looking for. So I have 66 and 2x plus 2. Well, we also have this little 90-degree symbol here. So I know, okay, so the relationship is complementary. And don't forget, in parentheses, that means equal to 90. So if I'm going to write my equation, I have part here, and then my whole is going to be 90. So 66 plus 2x plus 2 equals 90. If I were doing a proof here, I would say, okay, 66 and 2. So 2x plus 68, I can combine my like terms, would be my reason, equals 90. Subtract 68. 2x equals 22. And divide by 2, x equals 11. I think I did forget to write the directions on these. These were just a solve for x question. We will get into some plug-in ones later, but so in that case I am done. Okay, so on number 6 we're looking at these 10x minus 10 and 70. So it looks like together they form a straight line. So you could either say linear pair or supplementary. Okay, I'm okay with either, but you do need to specify that they equal 180 then. So I have two parts, and my whole will be 180. So then for my equation, I can do 70 plus 10x minus 10 equals 180. Combine like terms of 70 and negative 10. Remember, I don't need to do the opposite since they're just on the same side of the equals. So that's now 10x plus 60 equals 180 minus 60. 10x equals 120 and divide by 10. X gives you 12. Okay, I'm going to do one more here with you, and then I want you to pause and see if you can figure out the rest. So 7, the angles are across from each other. They only share a vertex, not a side here. So that property or relationship is vertical angles. I'll just say vertical. And the important part of that is that they are congruent. So I'm going to say for my equation, this isn't really a part equals whole. Your equal to part would say those two angles are equal, so, or congruent. So I take my first angle is 4x minus 9. I know congruent is the same as equals, so it equals the other. I would add 9 to give me 4x equals 44, and divide by 4 to get x equals 11. Okay, now I want you to take a minute here and try 8, 9, and 10. Start out with telling the property or the relationship, then set up your equation and solve for x. Okay, so you should be checking your work now. So first looking at number 8, those were complementary, and I knew that because we were talking about the two angles within that 90 degree there. So set my two parts equal to my whole, which was 90. Solve for x, which gave me 9. On number 9, they kind of threw this triangular business in here, but that's okay because we're just looking at the angle here. So the two of those together formed a line, so their total was going to be 180. Quick note, these parentheses don't really matter, because to show you this, if I give, so 5x plus 20 in parentheses plus 70. Well, since there's nothing outside those parentheses, it's essentially like distributing a 1, which wouldn't change anything. That would just make it 5x plus 20 plus 70. Okay, so I just kind of skipped that step rather than just, I don't really need to distribute 1. Okay, and lastly, these angles were across from each other, so they were vertical, which is congruent. So I set them equal to each other, solve to get x equals 17. Okay, for today's lesson, you need to complete the practice questions. You can either do that on Canvas as a markup, so it's the 1B.1 homework practice questions. I believe a student told me you can do that through the Canvas app is the easiest way. There are paper copies as well if you want one of those, and then there is a Canvas quiz. So once you have your answers, make sure you open that up, complete that. And there is also a assignment on Khan Academy. It's called Finding Angles. It should be quite simple, hopefully. All right, I hope you have a good day.